Hello guys, I am Ranjan M. Oliveros and for today we will be doing experiment number 15, up-down counter. This experiment illustrates the operation of a typical TTL up-down counter, the 74LS192. This IC is a fully synchronous 4-stage up-down BCD decade counter with parallel load and master reset inputs that can override the clock. So for our experiment today, we will be using the 74LS192, which is the up-down BCD counter. For the up-down BCD counter, next, an SPDT switch, a clock pulse, a VCC with 5 volts, and 6 LEDs. So as you can see here in the diagram, this is for the count-up figure. For the count-up figure, the pin 5, which is the up counter, is directly connected to the clock pulse and the down is connected to the VCC. So let's try to simulate. First, let's switch it to logic level low. Then let's start. As you can see here, in 5 and in 6 are at logic level 1 when the switch is at logic level 0. If we turned it on to logic level 1, there's a pattern that can be produced in 4, in 3, then back to in 4, then blinks, then in 3, blinks also, then goes to in 2, then goes back to in 4, then in 3, after the blink, then goes back to in 4, then blinks, then all of them blinks, then goes to in 1. After in 1 is at logic level 1, if in 4 is on, in 6 will blink and turn off. Then it will reset, go back to the same pattern as before. So that is the pattern for the up counter. So as you can see, in 6 or the LED 6 goes low when in 1 and in 4 at a logic level 1, in 6 goes at logic level 0. So what will happen if we disconnect the clock pulse? What will happen to the counting? If we disconnect the clock pulse and try to simulate, the counting will never start since it has no clock pulse. It can never set and reset. So next, for the next diagram, which is countdown, as you can see here, let's try to disconnect VCC and the clock pulse and connect the down, which is pin 4, to the clock pulse, and pin 5, which is up, to the VCC. Let's change it against the down. So now let's try to simulate and observe the pattern. So for the pattern here is, it's like the opposite of the count up. Then in 1, in 4 starts, then in 4 blinks, then in 1 turns off, then in 2, in 3, in 4 turns on, in 4 blinks once again, then in 3 turns off, in 4 turns on, then in 4 blinks, then in 2 turns off, then in 4 blinks once again, then in 4 turns on. Then if all of in 1, in 2, in 3, in 4, as you can see, in 5 will turn off. If in 1, in 2, in 3, in 4 at logic level 0, in 5 will become at logic level 0. So that's it for our experiment. I hope you guys learned for the up-down counter. Thank you for watching.